math module. So basically we have math module, just like random module, we have math module. But random module has different types of methods and functions. And in math, we have different types of functions and methods, just like sin h, cos. You have already seen using dir. Let's try to check them again. What are those? Just like let's go for Python first in your terminal. So here is the IDE basically, and if you try like import a math, import math directly, or you can also use from math import all. And but we want to check dir. So dir on math is, so you can see we have different methods, like if you do math dot underscore doc. So you can see documentation is like this module provides access to mathematical function defined by the C standard. So basically it's also using C standards of it as per developer. And so you can use all of them, and the same math dot underscore loader. So frozen import lib. So basically these are something which we don't need currently, but what we need to learn is the other functions like sine, cos, trigonometry, and these function we need to learn about. So for that we have like just wait a second. Okay, so we have very different types of functions for math also. Just like if you want to do 2 raised to power 4, you can do it like this. Even math also support this. Math has math.power method, which you can do this thing. But what if I say told you to find the value of log 10 and these all things? So for these reasons, you have to also use math module. So let's start with square root. Our first function which you're going to learn today is square root. So for that, it can be done with using math.sqrt. So take its input from user. Let's say square root of 4. Sorry, square root of 4. We got 2, and square root of 1. We got 1. And so in this way you can use it. And let's say square root of minus 1. So you can say it is math domain error. So it is going to take from maybe 0 also. Okay, so it is going to take from number from 0 up to any number, and also it is going to accept any number, and it returns suppose square root. Just like in math we have square root is equals to 1.414, and it is run up to until it is not going to end. So in this way you can get the value of square root 2. Now after this we have, you can also do it like math dot square root 2.5. Okay, it is also supporting decimal numbers, so it is for whole numbers. Math dot square root takes whole number. Let's try to check help on the math dot square root. What is it saying as per developer? So it is simple. Returns the square of 2x. There's nothing more than this. And after this, we have a math.power. Just like we have double asterisk method. Instead of that, we can directly use math.power method. So what does math.power method does? Let's try to check it. Math.power. You can say it is saying that it is going to take 2 arguments from the user, and it returns x double asterisk y. So it is just a function which is returning the same thing and nothing else. So let's try to get math.power. Let's try to print this 2 raised to power 5, which should be 32. Or not like this. We are going to use like this. So you can see we got 32. Okay, so in this way you can use math.power. And next one is math.factorial. So now what is math.factorial? Again, just check help on math.factorial. Here we are getting help on built-in function factorial in module math and factorial. It is going to take one argument from user. The slash is just like and or no argument. Just you can treat it like that. And it is going to return, basically it is finding n factorial. This exclamation mark is factorial in math. So it is representing here, exclamation mark here is factorial representation of mathematics. So if we try this math.factorial 5, it should be 120. So we are getting 120. For 4 it is 24. For 3 it should be 6. For 2 it should be 2. For 1 it should be 1. And for 0 it should be 0. And for negative number it should be invalid. Yeah, so value error factorial not defined for negative values. So factorial is also going to support whole numbers without decimal numbers. I think it is not going to support decimal numbers. Here you can see floating object cannot be interpreted as integer here. So basically it's saying you need to enter integer value. Now next one is math.ceil. Suppose if I will tell you a number in decimal, it's like 7.2, and what is the greatest number just after 7.2? For that, we are going to use math.ceil. So let's check help on math.ceil. Math.ceil. So if you try this, return the ceiling of x as an integral. This is the smallest integer. So basically, it is going to return the first integer, just like if I say 7.2. Okay, let's say n is equals to 7.2. And then my question is, after this, what is the smallest integer from n to infinity? What you will say? It is just after 7.2, which should be. So we have to start after 7 is not going to be there because 7.2, 7.3, and after we are going to 7.9, and then we are going to get 8. 7 is not there. Now 8, 9, up to that infinity. What is the smallest number we got? We got the smallest number as 8. Okay, so smallest number, if it is 8, what we need to do is like we are going to, so math.ceil is going to return this number 8. So if you want to get the smallest number from the given number up to infinity, we are going to use math.ceil. So let's try this. If you try it like math.ceil 7.2, it is returned 8. Similarly, if it is 4.2, let's say 4.9, it is just after just after 4.9 we have 5, so it was going to return 5. Let's say for 9.1 is not a round off and should not be confused with round off. Suppose 9 point round off 9.1 is 9, but 9 point ceil of 9.1 is the next integer after 9, which is 10. So we are going to get 10. So in this way you can use math.ceil function, and this is a mathematics thing, so you will need in your future needs. And in the same way we have math.floor. So let's check on math.floor. So if I try the math.floor, so here it's saying return the floor of x as an integral. So again it is showing nothing. So it is basically, let's say n is equals to 7.2, and if I ask a question after this, largest number from minus infinity to 7.2, what you will say for this? You will start from minus infinity, and then obviously we cannot show minus infinity plus 1, but for here we are just showing, and up to, it will go like 1 2 3 4 5 6 7, and it's not go to 8 because we have up to 7.2. So what is the largest number here what we got? It is 7. So math.flow should return 7 for 7.2. Okay, let's try for 7.2. So it is returning 7. For 8.1, 8.9, it is 8. So basically you can see it is integral part, but it is not only integral part. Suppose it's like int of 8.9 is also going to return 8, but int of minus 8, 8.9 is minus 8, but math.floor of this version should be minus 9. Let's try it. Math.floor of this minus 8.9, it is 9. Why? Because we need to get up to minus 8.9, and minus 9 is just smaller than minus 8.9. because number line is reversed in negative numbers. So that's why we are getting 8 minus 8.9. And next one is math.truncate. Okay, just like int, we have truncate, the same thing basically. If I use math.truncate, let's take a help on this first. Let's check what is actually developed by developer. Truncate. Okay, I made some mistake typo here. trunc. Okay, truncates the real x to the nearest integer towards 0. Okay, it is not going to remove like decimal. It is like nearest towards decimal, and which is same thing which int do, because mathematically they are going to land up on the same function. So math.truncate minus 8.9. You can see I got minus 8, and for plus 8.9 I again got 8. So why is that? Because so just integer. So if you try to approach to 0, what is the first integer you got if you start from minus 8.9? So for going to 0 and your number is already negative, you should add the number. So if we add any number in this, we are like at 0 0.1, 0 0.2, so it's like minus 8.76543. We got minus 8 as first integer. And if you have positive integer like 8.9, you need to subtract it. So if you try to subtract, we got 8. So in this, that's how you are going to get 8 number as a math.truncate. Now next one, we have math.fabs. So let's try what is this math.fabs. Okay, we have next function which is math.fabs. Okay, returns the absolute value. And we have also one function which is abs. It is also returns the absolute value. Okay, so it is also returns the absolute value of argument. Okay, let's try for abs. Let's try for math.fabs. Maybe it is all for all numbers. Let's say if I pass 3, it returns with 3. For minus 3, it returns minus 3. For minus 3.3, again this number. Okay, now let's try with abs. If I try with 2, if I try with minus 2, and if I try with 2.3. Okay, so it is same as math.fabs. If fabs is same as abs, just like it has a math function, just like we have two double asterisk square, which is squaring and powering function, and we have also math.power function. In the same way, fabs is also math function, math module function, which is also a built-in function matching with abs of built-in function of Python. Okay, so now next one is math.gcd. Okay, now let's try for math.gcd. Okay, so let's try to take help on math.gcd. It is not necessary to take help, but you can just take. Okay, so here you can see it is showing a star on integers. So I think it is not GCD for only two numbers. It may take more than two numbers. So let's try first on only a number. Okay, math.gcd of 4. Okay, so for one number is also running. For two numbers, it is still working. For three numbers. So you can see it is work for a sequence of given numbers as argument. Hmm. So in this way, you can use a GCD program, GCD code for getting multiple number GCD if you want. Just uh, pass as one by one argument in and just increase them by one. So in this way, you can use it like this. Now in the same way, we have next one which is math.lcm. Let's try to take help on math.lcm. So again, it is taking multiple integers as an argument, and so it is also not depending on how much it's like how much arguments we are passing. It is going to take all of the arguments, and it will going to work on all of them. So let's take LCM of a single number. Okay, again math dot LCM. Here is showing 4. Now let's say 4 and 2. It is again 4. Let's say 9. So it is 36. Let's make it smaller. 3. So it is again 12. Now 21. It's now 84. So in this way, you can use a math.lcm function for your math using math module. Now next one we have math.sin. Okay, if you have passed 12, 10th and 11, 9, 10, 11, 12, you may have come across this function sine, cos, tan, sec, cos. It's like these function, and also we have inverse of them. So let's try that. Before sine, cos, tan, I want to tell you what is math.degree and math.radians, because these are helpful very. It's like let's try for math.degrees. You can say convert angle x from radians to degree. So it is going to x. It is already developer makes that to consider that x here x is has unit degree of radians. So if you don't know about radians is a basically a unit of angle, and we need to convert it to degree. And let's say if you want to convert that degree, if you want to convert your angle which is given in degree to radians, you need to use math.radians. So let's take help on math.radians. So convert angle x from degrees to radians. So basically it is a conversion function which is used to convert from radians to degree or degrees to radians. And make sure that return type is the same as the function. So you are not going to confuse which one is to which one going to convert. Okay, so let's try for help for math.sin. So you can see sin x, return the sine of x measured in radians. So it is already saying x is measured in radians. But it is a little bit difficult for us because in general we always measure using protractor and it is given in degrees. So let's try to convert our angle. Let's say try to find a sine angle for 30 degree. So angle equals to math dot. We are going to convert this radians, so we are going to using radians function. And we need for 30, so for 30 and math dot sine of angle, it is 0.4994. So if you calculate it by yourself, you may got 1 by 2, and 1 by 2 is equal to 0.5, and 0.5 is approximately 0.4994. There is floating point error in Python. So if you round off this, just for example round of math dot sine, I will tell you what is some more functions like round abs like this later. Okay, so you can see we got 0.5. In the same way, you can also take help on math.sin and more functions like math.cos, math.tan. Okay, it is only going to take one at a one time. I thought it is also multiple capacity. So here you can see. Now if we run this, so same for cos, same for tan, and atan is just the inverse. So you can see return the arctangent. So and you can also see the result is between minus pi by 2 and pi by 2. So if you have learned about inverse trigonometry, so tan inverse will return its value from minus 90 to plus 90. So this pi by 2 is 90 degree. And let's try for acos. Acos is I think 0 to pi maybe. Yeah, so it is acos is 0 to pi because cos inverse will return your value from 0 degree to 90 degree to 180 degree. And one more thing, 180 degree is equals to pi radians. Basically, if you have encountered this, just like if you have 180 in degrees, then it is equals to math.pi in radians. So 180 is equals to 3.14159 likewise. So you can, and after this you can use reciprocal system to in mathematics to get all of the values of degree and radians. Now we have covered this like, and also we have asin in the similar way. Asin format dot. Okay, if you try for asin, so I think this one should be also minus 90 to plus 90. So yeah, it is pi is 180 and minus 90 to 1 to 90 to plus 90. So in this way you can use all of these given like trigonometric functions. And one more thing I want to tell how you are going to use. Okay, I've already tell, I think here it was like you will first convert if you are going to enter in degree. So you need to first convert your angle of your degree into radians and save it into another variable or directly pass it as argument here for math.sin because math.sin is going to take input as radians for angle. So if you are inputting in the form of radians, then it's okay. But if you are going to input in the form of taking argument in the form of angle, I mean degree unit, then you need to use we called you need to use math.radians to convert it first that degree to radian. Okay, so our next one is okay. These are the trigonometries one, and we have next one is math.log. So if you have learned that log function, you know about it. Then it is like let's run for this math.log. So log, if you don't know log, what is logarithm? If you try to search on log on direct, you will get a function, and also you will also make a graph which is goes like this. It is goes like if I can show you. Suppose here you can see plus if I can show here I have highlighting color. Okay, so like this, and after that we have like this, and your logarithm will go from here. It will goes here. Just a second. It goes like this way. Like you may got this now. No, not in this way. Basically, it just starts from here. First, it will go straight like this, and it will intersect at 1, and after that, it will go like this in this form. So this is the log x. You will also going to cover this in time complexity and space complexity topic. If you are ever going to do DSA, you will got log x graph like this, and here is 1 at the intersection. So therefore, we got math.log1 as 0. Yeah, so at 1 at x equals to 1, our height of this blue line is 0. At this we have some height, at this height 0. So therefore math.log1 is 0. So here it's 0 height. So in this way you can use math.log function. And let's say for 2 math.log2. Okay, let's try for math.log0. So you can see it is saying value error, math domain error. So here you can see one more thing here is it is never going to touch this line. So therefore we are never going to get math.log0. It is infinity, negative or infinity basically. So now next we have exponential. Exponential is like e to the power raising something, something raising to power e to power x. It's like math dot. If we let's try help. Oh. math dot math dot log. So I can see by default it is okay. One more thing. By default it's taking base e. If I enter something else, for example, if I enter base as 2, it is showing 1. Now it is going to show the power of how much power is. So 4 is the square of 2, therefore it returns 2. Now 8 is cube of 2, so it is returning 3. Now 16 is power 4 of 2, so therefore it returns 4. So basically it's going to return the first arguments, just like you are going to take second, just like it is going to answer how much power you need to raise on second argument to get the first argument. So that is the value which is going to return by the math.log x, y, x comma y. Now after this we have some more things like math.e, math.pi. Suppose we have like math.e, math.pi, math.inf, math. We have more one. I'm just for yeah math.nan, and so that's it. That's how you're going to use this. And if you want to create something, you can use these things to create. Okay. So let's try to create one program on using math module. So what we're going to create, we're going to create one math module in which you can either add, subtract, calculate, log, and sin x, cos x, whatever function you need. So let's try this. Okay, first we are going to use import math. First thing, which is okay. Now after this, we are going to print a function, which whatever function we are going to, and also after that we are going to save all of these things in CSV file as a history for history purpose. So okay, while true. So what does while true? I haven't tried. You haven't tried while true for a while. So while true is used when you don't want to end your loop on its own. If you want to, let's say it has some condition which can be random, but while true is used when you want to run your program forever. So this program is not now going to never be stopped until unless if I make something to break it, because break is used to break the while loop also. So you can control your while loop using break keyword. Okay, so let's print. So I'm using multiple string, multiple doc function to use this. Select operation. Okay, now we're going to like we can select something this and just remove it, or you can just put it, no issues. Okay, now let's go with next line. Okay, so we are going to add first operations like add, second operation subtract, third operation multiply, fourth operation divide. Okay, now after this we are going to create some more functions likewise for us, let's suppose for a square root, for cube root, like this way. So instead of that we are going to create one program which is nth root. So let's first try, does math.pau supports negative function? So okay, it does support negative function. Okay, so we are going to use it like fifth one is root, and sixth one is power. Now after this we are going to use, we have like, we can use something. Okay, we have LCM and GCD. So okay, so let's say seventh one will be LCM, eighth one will be like GCD, and after this we are going to make for ninth one for the logarithm. Okay, so that's all we are going to print first. So okay, we have 9 operations in total. If we can add one more. Okay, we have main things are remaining, which is trigonometry. 10 dot sine, 11 dot cos, 12 dot tan, 13 dot asin, 14 dot acos, 15 dot atan. Okay, if you want all of the lines to be smaller, we can make it, it's your choice. Now after this, okay, let's take a choice from the user. Now today we are going to use switch statement. Although I have not heard, but it is very simple. So for this, you need to take switch. Let's first take input from the user. X equals to int input. And if I want to use try except here, you can use it. For making it more complex, it will be a great project for you. Enter your choice. Okay, now after this, what we are going to do, we are going to use switch X. Uh, keyword dot soft kw list. We don't have switch in. Okay, so we have match case. It is not like, so it is switch statement, but it is match case like, but like in other language we have match. Like in other language we use switch, but in this language we have the match case like. So we have match. So we need to use match X and then just press enter. So basically it is just like if then else, but instead of using multiple if then else, it is directly going to use executors like this. So case 1. So this is a code block that is going to execute and when it is 1, when x is equals to 1. So for 1 we need 2 input. Okay, so we need 2 input. So what we are going to do, we are going to do like taking a 2 input from the user. So a equals to int input, enter a, b equals to int input, enter b. Okay, now after this, as you can see, we need to do this thing multiple times. Okay, so we are going to create it as a function. We are going to create it as function def multi input. Let's say we are going to use it that multi input, and it has n, and l is equals to empty for I in range, and l dot append enter your number. Okay, And also we may sometimes need like enter. We need variable also, just like for number we need number, for log base, likewise. So we are going to create enter modulo s. You can also use modulo here, modulo uh, modulo lis of I, and we are going to take input for lis also. Not here, it's like list. We are going to enter lis in the form of list. Okay, so now after this we are going to take multi input. So instead of writing this line multiple times, multi input 2, it is num1, it is num2. Okay, argument is equals to like this, and just pass this and just return the sum. So result is equals to sum of the arg, or to be more better you can use it like this. Argument is 0, because there is only two number, we don't need to use sum, we can use it directly. And again after this input 2, and this time we need to do subtraction, because on second one we have subtraction, on third one and fourth one we have multiply and divide. Okay, so third one we have multiply, fourth one we have delete, or not delete, I mean divide. After this we have the root and power. So okay, now for root and power we again going to need this, and what you are going to case 5, and this one is case 6. So for this one basically we need to make it like, for example, math.power, help on math.power. We can say it as a base and raised to base and power. In the same way here, base and the root. So okay, so in this way we are going to use for case 5 and 6. Next one is LCM and GCD. So for this one we are again going for this. So it is for case 7, and case 7 is like taking multiple inputs from the user. So let's suppose there are 7 inputs from the user. So how we can declare it? So okay, so we are going to take input here for that thing. Let's take n is equals to int input, enter number list. Basically enter what we're going to enter here is like entering a number of enter length of your number list. Okay, so n is equals to this one and argument is it is equals to n, and we are going to use create a string which is num plus a string of I plus 1 for I in range n. Okay, so now after this we need one more thing. So after this, what we're going to do, we are directly pass that arg, but make sure to also use a star. So math.gcd and then a star of the arg. Okay, now after this, so in this way you will get the result for GCD and LCM. Now after this we have one more code, so it is getting a little longer basically. Let's go for it, no issues. Our code is enough modular to make it. So for case 9, suppose if x is equals to 9, what we have, let's take help on math.log. So it has base and number. So we are going to input is like arg is equals to multi-input, and after this we are going to take, we have two inputs and which are which are number and base. Now result is equals to math.log arg of 0 and then arg of 1. Now after this we have just few more sine, cos, tan. So basically these all are the same things, but they are the same thing but with a different function. Okay, so we are going to use case 10. So for case 10 we are going to take a single argument. It's like only one argument, so we can directly take input and we are going to take input in the form of degree because it is more efficient for us. So enter angle now we're going to enter angle and then math dot result is equals to math dot sine of math dot radians, because we are going to convert this into radians. Okay, now so same thing we are going to do with the r same thing we are going to do with the cos, tan, atan, similarly all of the things. So just copying this. Okay, now let's change this math.10 to 11. This one is 12 cos tan. So in this way we have used this for tan. Okay, one more thing. Okay, now after this we are again going to take input, copy and paste the same, and now this time 13, 14, 15. Okay, now here I'm not going to enter angle, enter value. Let's say if I try help on math.sin. Enter a value, because these are going to convert this to value. So now after this, what we are going to do, we are going to print this result. Okay, now print this result like this. We are going to print in the form of, we are going to directly print basically. So if it is integer, it is integer. And at the end, we also want to add this to our history. So for that, we are going to opening our file. Okay, and let's suppose the file does not exist. So, okay, we are not going for error part right now. We are just creating simple file. So file is equals to open. So just create a one file folder and then history.txt. Okay, I will saving this in the form CSV. So you can see I got history.csv here, and I'm going to open folder and then history.csv, and we are going to write basically, not write, we are going to append. And one important thing, I forgot to make one which is important, 16 for exit. Okay, so file is opened, and if you want to write, it will going to write like csv.write result. So currently you are only storing result section, not csv.write result, csv.writer. So in this way we are going to create one object. So we need to only create object only one time, so don't create it multiple times in while loop. And after this, wr dot right row result. Okay, so in this way you can write your row. And let me to make, okay, let's also save the function number. We can at least save the function number, because saving function name will take more time here. So I'm just going for the name. number function. Should I create name? Okay, let's create name, no matter. We have time. Function list. Fun equals to add, subtract, multiply, and divide, and so on. So just like root and so on, you have to create like this function. I mean, for not function, pow, just a short form, and then we have LCM, and then we have GCD, and then we have log sine cos tan, sine cos tan, asine, acos, atan. Okay, now instead of that, let's make first one to be exit. We are going to create null, so we don't need to do any manipulation, anything, and then exit. So we are going to use function of I. So we have error somewhere right now. So let's check that error. Okay, I is not defined. Okay, so it's not I, it is basically X. So in this way, you can create a calculator program, and if you want to take a snapshot of this, you can either take it, or let me tell you how to post this on GitHub if you want. I will post this on GitHub, and if you want to know how to do this, how to post these things on GitHub repo, I will tell you later. So that's it all for today, and it got stopped. So that's all for it, and just keep practicing and keep coding. And we have next on next time we are going to learn about some more modules like time module, date time module, and SYS module. Since we have used SYS module in previous second lecture, I will also going to tell you in depth how to use it. So that's all for today. Thank you.